Hello, calculus, and welcome to 3.2. This one here is about continuity. So is a graph continuous or discontinuous? And we need to use this here for later on in our derivatives, so we need to make sure we understand and ask good questions. And let's get going. Okay, we need to determine a point continuity. So is it only discontinuous at a point? We need to know if there's interval continuity. So is it continuous on certain intervals? And if a function is continuous everywhere. So let's go through here and look at some of these things. We know it's continuous if at f of c is defined. So at the value, it actually has one, not like a limit last time. So remember how last time our limits could equal a number, but there would actually be no value? That's not true at continuity. This time the limit has to exist for the left and the right, and then at c, it has to be the same. So everything has to be there in order for it to be continuous. If that's not true, then it's discontinuous. So let's look here. We're just going to look at a graph to see if we can understand. So at 1985, we're going to go up to 1985. And at 1985, this equals 3.5. So right here. So we would say this is continuous at 1985 because at 1985, it equals 3.5. All right. And if you look from the left, it approaches 3.5. And from the right, it approaches 3.5. So the limit's 3.5. So the limit of 1985 is 3.5, and it is continuous at that point. Okay, now let's look at 2000. If we go to 2000, we're over here. All right, at 2000, we have issues because at 2000s, I have a value of 5, right? But the limit as we approach from 2000 from the left is right here. It's going to approach lower than 5, whatever that is, 4.9, okay? And then as we approach from the right, it's 5. So this is 4.9. This is 5. It's not the same. Since all three are not the same, it is discontinuous. It does not have a value. So the answer is no, this is not continuous. It is discontinuous. Okay, try yours. 1958, so you should have went here, and you should have saw the same problem. It has a value of 1. It approaches 1 from the right, but from the left, it approaches like 0.9. So this is bad, so this is no. It is discontinuous. Okay, I hope you're getting it. So now let's go over here. Is the function continuous at -3? Try this. Well, -3 is here because it's going by 3's. The answer is yes, because at -3, so the function at -3 is equal to -1, sorry, 0. Okay, and as we approach from this way, from the left, it's 0, and from the right, it's also 0, since all three are 0, so it approaches -3, it approaches 0, from the left, and as f of x approaches -3 from the right, it is also 0. Since all three are 0, the answer is yes, it is continuous. All right, now let's look at 3. So when you went from 3, so f of 3 does not have a value, right? It's undefined. There's no value. Since there's no value, it cannot be continuous. So the answer is no, it's discontinuous. And you didn't even have to check the rest because all three have to be true. All right, let's see how you did on this one. So we check. So what is the function as x approaches 0 from the left? And we look here and we get -1. All right, I forgot to write the f of x actually has a value because it's closed here. It's -1, so we're doing well so far. And f of x as x approaches 0 from the right is 1. They are not all three the same, so it is discontinuous. All right, how'd you do at the 4? Okay, let's go here. So I know f of x, f of 4 is equal to 1. So that's good. But f of x as x approaches 4 is equal to -2. These are not the same. I don't have to continue. This is discontinuous. Okay, is the function continuous at -2? Well, the function at -2 is undefined, right? It is approaching positive infinity, therefore it is discontinuous at -2. Just for your information, from here to here, though, it is continuous, not inclusive of -2. All right, so to tell if a function is continuous over a closed interval, first of all, we look over the open interval. Is this part continuous? The answer is yes. We got our first part done. And then we look, is it continuous from the right as x equals a? So if I go from the right and I approach here, does it approach a number? And then if I approach here, does it approach a number? And the answer is yes both times. Then we are good and the function is continuous. So we look here at -1 to 1. First of all, yes, it's continuous all the way through. There's nothing that has an open circle or anything like that, right? Now, continuous at -1. So we go -1 from the right, and it's continuous, and -1 has a value. Continuous at 1 from the left. We go here, it's approaching our 1, and it has a value. So they both approach 0. We are good. Okay, try yours. I want to know if this is continuous from -1 to 3. Well, from -1 to 3 is the open interval continuous. So from -1 to 3, is there any problems from here to here? The answer is no. This is good. So the answer is yes. Okay, so as we approach -1 from, as we approach -1 from the left. I'm sorry, from the right. I don't know my left and right today. Okay, is it continuous? The answer is yes. As we go up here, we approach -1, it equals 2, so yes. How about 1 from the left? So from the left, 3. So from the left, we go down to 3, it approaches -1, so we have a value, and the answer is yes. So this is continuous from here to here, so yes, it is continuous. How about from -1 to 4? Well, we know the open interval from -1 to 4 is good, it is continuous. We know at -1 we have a value, right? So this is continuous here. And let's look at 4. The value is not continuous because it approaches -2, but the value of 4 is 1. So the answer is approaches -2, but the value equals 1. So the answer is no. So this one is discontinuous on that section. All right, let's look here. These are just a couple of interesting. When you look at this, when you draw this one here, it is continuous everywhere. There's no place that causes issues, right? There's no open circles. There's nothing that doesn't work. This one here is not, it's continuous from here to here. It is continuous from here to here. It is not continuous from here to here because we have an area right through here where there's no value. So that is discontinuous there. All right, so here, this is good. Anywhere from here over, it is continuous. So it's good on the interval where this has a value. So right here, this is ax plus b. So wherever this is positive, we have a value, and it's continuous there. It is not continuous if it is less than that because there's no value here. This one is continuous everywhere because it goes this way on up and it goes down this way forever. It has no issues. It is always continuous on x. This one is continuous when x is greater than 0. So on this side, there is no value. So they all have continuous sections, but there are parts that could cause issues. So now we want to find where this guy, value of the function is discontinuous. So what can this not be? So when we look at this one here, it cannot be negative because it's under the square root. So this is what we look at. So we go f, our 5x plus 3 has to be greater than equal to 0. Just solve it. So we're going to subtract the 3, divide by 5. So x has to be greater than equal to negative 3/5. All right, and this is where it is continuous. So therefore it is discontinuous. So this is where it's continuous. So this is where it's good. So it's discontinuous on the opposite of this, which would mean x is less than negative 3/5. Not inclusive. The equal sign goes here because it was equal to this. Okay, whereas this discontinuous, what cannot happen is I cannot divide by 0. So all I have to do is set the denominator equal to 0, add your 7, divide by 2. So x cannot be equal to 7/2, and the rest of it is where it is good. All right, when you're looking at piecewise functions, you have to be careful. The parts we're always interested are the changing sections. So like this changes from 1 to, and this one here changes at 3. So I need to check 1 and 3 to see if this is continuous or discontinuous. So I'm going to check 1 first, and we're going to check when x approaches 1 from the left. So that's the less than, so that's the x plus 1 function. So I put x plus 1, I plug the 1 in, and we get 2. So then I need to check it from the right, which is this one, because x is greater than, so now we're using this function. We plug in the 1 and we also get 2. Since 2 is true both sides, it is continuous at 1. All right, so this is continuous at 1. Okay, now let's check 3. So 3 from the left would be this function since it is less than. So we plug in 3 and we get 7. It's greater than 3 here, so now we plug in 3 in this one here from the right, and we get 2. 2 different numbers, so this is discontinuous at 3. And this is what it looks like. Your first line meets the parabola here and goes up. It never loses continuity because there's always a value. Okay, this line does not meet the parabola, so there's a jump in here, so it's discontinuous at that point. All right, now let's try yours. So you should be checking 0 and 3. So I need the limit as x approaches 0 from the left. Well, that's the less than, so this is this one. So we're going to check the 5x minus 4, and that's going to give us negative 4. Now we're going to check the limit as x approaches 0 from the right. So this is greater than, so we're using this one. So we got x squared, so that equals 0. These two are different, so the answer is discontinuous at 0. Now let's check the other one. So the limit as x approaches 3 from the left. So this is the less than one, so that's this one. So we're going to do that into the x squared. So we're going to plug in 3 and we're going to get 9. Now we need to check the limit as x approaches 3 from the right. So that's the greater than. So that's this one. We're going to plug in the x plus 6. That's also going to give us 9. These are the same. So it is continuous at 3. I hope you did well on those. All right, now let's just do a little bit of story problems and we're done for the day. Okay, cost analysis. A trailer rental company charges $8 to rent a hitch and the cost is $22 per day. Where's the function discontinuous? So where does this thing not, or when do the values not match? And if you look, it's here 1, 2, 3, 4, right? And it just continues forever. So it is discontinuous. Can't spell. at the start of the day, of a new day. I'm kind of hoping you remember this function is a step value. It's starting at 30 because your first thing you pay is 22 plus 8. So it starts at 30 for your y-intercept, and then it jumps by $22 a day. But now, remember your step function? This is just for fun because this is your greatest integer function. So all these values, if it's are always equal to the same amount. So once you get to 1.1 day, the minute you keep it over an hour longer, you're jumping up to another day's rate. And it just keeps jumping to your day's rate. Your step function. Good luck on your homework. Make sure you post questions.